Hi, it's Miss Molesbury here. I'm going to try to do a kind of quick redo of this video that didn't work before over solving rational equations. So I'm going to work some of them from the back because I had already done this part of the notes. I know that video didn't work correctly, but hopefully this will help if you're still having questions. What we had said our first step is on these questions, we don't get excited to solve equations that have fractions in them. Like nobody does. So if we can find the least common denominator and multiply each part of the equation by the LCD, it'll cancel out all of our denominators. So those are our steps. That's our first step, and really the only thing that is new, because everything else is going to rely on your Algebra 1 solving skills. We're also on the lookout for extraneous solutions. So they are solutions that make any term of the equation undefined. They would make our equation untrue. And so we're basically on this looking for any restricted values. So that's why we were doing restricted values on our addition and subtraction J, just to be on the lookout for them, since they are not possible solutions to these rational equations. So I'm actually going to go to the back of the notes. You're welcome to go to Canvas and check any of these on Canvas. But on the back page, I'm going to start with number 6. This one actually, as people worked it in class, ended up being trickier than expected. And let's see why. So our common denominator, I have a 3 and a 12 and a 4. So I'm going to think of my least common denominator here. Looks like I could use 12. No need to multiply 3 and 4 and 12 together, since 3 and 4 can both become 12. On this one, there are no restrictions because there's no way that any of the denominators could become 0. They're all numbers. So I'm going to take my entire equation and go multiply by 12. Now it could be helpful here to think of 12 as 3 times 4. So we're still multiplying by 12, but that way it's going to help me visualize as I multiply the first fraction by 12, the 3's would cancel out. Okay, so I'm going to erase this canceling out 3 because I'm going to use the 3 times 4 again. But if the 3's cancel out, then the x minus 5 is only multiplying by 4. In the second fraction, when I multiply by 3 times 4, that means all of 12 is going to cancel out. Since it is 3 times 4, if we multiply by a 3 and a 4 and it was divided by 12, the 3 and 4 cancel. In my third fraction, if I go multiply by 12, 3 times 4, the 4 would cancel and the 3 would be left with the x. Oh, so let me figure out. The second fraction left x minus 38, everything from the denominator canceled. The third fraction left a 3 with x. Now, if this is confusing to you, over to the side, I'm going to write what we just did. We did 12 times the first fraction, 12 times the second fraction, 12 times the third fraction, and we just simplified it quickly. So let's see what we did here. I didn't write all these steps, but we know that 12 divided by 3 would leave us this 4 right here. We know 12 divided by 12 in the middle fraction canceled and left us x minus 38. And then we also know that 12 divided by 4 is 3. So that's why I just wrote 3x. Everything from here is an Algebra 1 step. So we want to distribute 4x minus 20 equals x minus 38 minus 3x. Let's combine like terms. So let's see, negative 2x minus 38. I'm going to go ahead and move my 2x to the other side. So it's going to become plus 2x. So I have a 6x equaling. And when I add 20 to the other side, I'm going to get negative 18. So dividing by 6, x is going to be -3. There were no restrictions, so no extraneous solutions as a possibility here. Okay, let's try number 7. So same idea, but this time I have variables in my denominator. Let's factor first to see what they have in common. So on the right, I have x plus 7 and x minus 5. So it looks like my least common denominator on this question, make some space, is x plus 7 and the x minus 5 that they share. And I'm going to have to make sure that x does not equal -7 or 5 because those are my restrictions that would make me divide by 0. Okay, so next part, let's go multiply each fraction by x plus 7 and x minus 5. So on the left side, the x minus 5 would cancel, and I would just have x plus 7 times that 1. On the right side, everything would cancel, and the 5 would just be left alone. So I have a super easy equation to solve here, just x plus 7 equals 5, so x must be -2. And before I box it, I glanced to make sure -2 is not a restricted value. Okay, let's keep going. Number 8, same process. We need a factor first to see if we have anything in common already. So even if it's just a GCF, we want to go ahead and take that 5 out. Then I see difference of perfect squares. And now let's go look through our question. We have an x minus 1, an x plus 1, and I also have to put a single 5 in my common denominator since the second fraction had a 5. I don't need to list any of these twice because none of the fractions have any of them 2 times in a single denominator. So my restrictions are only going to be 1 and -1. 5 won't make a restriction because there's no way that 5 could become 0. All right, let's go through and multiply by 5 times x minus 1 times x plus 1. Whatever the fraction already has will cancel out. So x minus 1 would cancel, and 3 will be left multiplying by the 5 and x plus 1. In the second fraction, the 5 and x plus 1 that we're multiplying by would cancel out, so only x minus 1 would be left with that 2. Oops, there we go. And then on the right side, the x plus 1 and minus 1 would both cancel, so the -3 will only be left multiplying by the 5. And now it's algebra 1. I'm going to think of this as a 15 that I'm distributing, a 2 that I'm distributing here, and let's go solve. I have combining like terms. I have 17x plus 13 equals -15. I'm going to subtract 13. 17x equals -28. We don't get a warm fuzzy feeling from this answer, but we did not do anything incorrectly. So it's okay to get a rational answer. -28 over 17. Please leave it as an improper fraction. Don't try to convert it to a mixed number, and please don't type it in the calculator. We don't want it to be a rounded answer. This is actually the best, most exact thing you can do, and you don't have to do any extra thought to get there. Okay, let's try another one. So number 9, let's factor first. Hopefully these steps are becoming more familiar. And you can see it's just the same thing over and over. So it looks like I can factor this last fraction into x plus 3 and x minus 2, which will end up being my least common denominator. X cannot be -3 or 2. And then let's go solve. So the whole entire problem gets multiplied by x plus 3 and x minus 2 in order to cancel out all the denominators. The x plus 3 cancels, so -2 is left multiplying by x minus 2. In the second fraction, the x minus 2 cancels, so 3 is left multiplying by x plus 3. In the final fraction, both terms, or both binomials cancel, so 5 is left alone. And then we get to distribute. And combine like terms. Looks like I'm getting x plus 13 equals 5. Subtract that 13, so x is going to equal -8. And I'll double check it is not a restricted value, so it is a valid solution. I don't know if any on this side have extraneous solutions or not, but if not, you can always ask your teacher or go back to that example on the front that did. Let's go ahead and finish it out with number 10. 10 says 3 over x squared plus 2x equals 6 over x squared. I'm going to factor out a GCF. And now for my least common denominator, there were some questions here in class about this one. The right side has x squared, meaning it has x times x. So my least common denominator needs to have x squared and x plus 2. Having just one x in the least common denominator would not be enough because this fraction has 2 x's multiplying. So now as I go through, we're going to multiply both sides by x squared and x plus 2. So in my first fraction, it's going to make the x plus 2 cancel, one of the x's cancel, and 3 will be left with the other x. On the right side, both x's, the x squared will cancel, and 6 will just be left with x plus 2. And now we're just going to distribute. Subtract 6x. And divide by -3. So I get -4. Oh, I didn't list my restrictions. It looks like x could not be 0 from the x squared or -2. So -4 it is. None of these were extraneous. But again, if you go back to the example on the front, I know there's at least one where if you get a restricted value, then it doesn't work as a solution. So hopefully this helps, and please let your teacher know if you have any questions.